Dgraph took the approach of optimizing for scalability in terms of volume, and so the D in Dgraph is distributed, and so Dgraph does sharding out of the box. It's built on a distributed key value store that was actually purpose built for Dgraph called Badger, which is another now open source project that we maintain at Hypermode. But Dgraph takes this approach of exposing to, like, at query time to the developer. I think it still exposes a property graph model, but also internally works with this concept of triples.
Welcome to GraphGeeks in Discussion. I'm Amy Hodler. Today we're speaking with Will Lyon, a friend and veteran in the graph space, about his journey going from Neo4j to Dgraph. So join us for an insider's perspective on trends and different approaches to graph databases. Welcome, Will. It's good to see you again.
Yeah, hey, thanks, Amy. Thanks, everyone, for joining today. It's fun.
Awesome. So Will, tell us a little bit about that journey. So that's about a 10-year, maybe 10-year plus journey, going from one type of graph to now a different type of graph. Like, what were some of the major things you've seen along the years?
Yeah, so I think my first exposure to Neo4j, I want to say that this was like 2011, 2012 maybe.
Mm-hmm.
So I was working as a software developer, and meanwhile I was also working on a master's degree in computer science, very, very part-time. I'd take like one or two classes at a time. I think it took me like 8 years to do the master's degree. And so I was on the lookout for, something interesting to do for my thesis as part of my master's degree. And I was at a hackathon, and it was pretty open-ended. We just needed to build, I don't remember what the prompt was, build something interesting. And we saw a Hacker News article earlier that day that was introducing, I want to say this was maybe like the Neo4j 2.0 launch, which introduced like labels to the property graph model, and was a big jump up in the developer tooling with like a new version of the Neo4j browser and new pieces of Cypher. Like Cypher, I think, was in its infancy at that point. And that was really captivating to me. It was like this idea of graph pattern matching with Cypher. You draw some like ASCII art representations of the graph you want to look for. And that really resonated with me. And so we were like, okay, we're going to do something with Neo4j for our hackathon project. And we built a GitHub repo recommender system. So you would sign in with your GitHub user, and we'd crawl the GitHub API to find, like, okay, what kind of repos have you starred and who are you following? Because there actually is like a pretty interesting social network aspect to GitHub. And so anyway, so that was my first exposure to Neo4j, and I want to say like 2012. I think we won the hackathon, or maybe we got second place. I don't know. Something
Are people still using the GitHub recommender system?
I hope not. It's the code is out there. I could probably dig it up. It's on my GitHub somewhere. I can't remember what we called it. It's my friend George and I worked on several projects going forward. Nice. Yeah, and that was actually the topic of my thesis for my master's degree, was link prediction using this triadic closeness metric, which is, if you think of an unclosed triad in the graph, you have like nodes A, B, C, and A is connected to B, C is connected to B, but A and C are not connected. And then if you look further in time, as that triad is closed, so when A and C become connected, if you have directed nodes, there are like so many different patterns of ways that triad can be closed. And this measure of triadic closeness is looking at the structure of these open triads, and then when they're closed, like if you have, I don't know, like a relationship from A to B and like two relationships from B to C, is that more likely to be closed with a relationship this way from A to C? And it's really easy to express all those different combinations in Cypher. And so my thesis was basically scrape a bunch of GitHub data and look at, statistically over time with cipher patterns for identifying all these different types of triads, calculate the likelihood that each one is closed, and build a little ensemble machine learning model for link prediction was the focus. So it's basically just an extension of that hackathon project for my thesis.
Yeah. Nice way to double dip on the concept. For those that don't know, Will and I actually work together at Neo4j. Will, I don't know if you know, there used to be a joke that another colleague, Jim Weber, couldn't do a presentation without triangles. And so there's a special place in the hearts of graphy people for triangles, whether they're closed yet or not.
Totally. And yeah, and at that point in time, I'm going to totally space on the name of this book, but Amy, I think you'll know this, the Kleinberg book.
Oh yes. Don't. Yes. Still ask me the name of the book.
Which is so Kleinberg, he's a professor at Cornell, I want to say maybe. And it's actually like a freshman economics book, but all in the context of graphs and networks. And there's a chapter in there that I think where a lot of like what Jim Weber would talk about with triangles is like, the outcome of, or I'd say like the way that World War II unfolded with, the countries that are allies is like can be predicted from if you look at World War I time frame, right? Like, enemy of my enemy and like all these sorts of things, I think is the example they use in the Kleinberg book. So yeah, that was a big, at that time, a big resource that I was reading through. And that was, I think, like a big introduction to graph theory for me was that Kleinberg book.
Awesome. So thinking about going from the early days of Neo4j and kind of moving forward, and remind me again how long you were there, and like what other big changes you've seen in the graph space.
Yeah, so that was kind of like my first exposure to Neo4j, and then I worked for a couple of startups and actually used Neo4j, and we. Let me back up a little bit. Also, when I was still in school, I did a Google Summer of Code project with Craig Travner, who at the time had a startup that was using Neo4j for cell tower analysis. And so he had written a plugin for Neo4j. This was an unmanaged extension. And so at the time, you would write Java code, ship it to the database, and then that would add like an endpoint to the REST API that the database exposed. There wasn't yet a way to leverage those extensions in Cypher. And he had written a plugin that added geospatial functionality to Neo4j. And so being able to represent like complex geometries like polygons and multi-polygons, and doing like point and polygon or see where like multiple polygons like intersect, doing these sorts of queries using an index. And so anyway, my like internship Google Summer of Code project was with the OSGeo group, but mentored by Craig, who later on went to join Neo4j and build some of this functionality in Neo4j. And then also Michael Hunger was another one of my mentors. And that was my first exposure to Michael. And I think a lot of your listeners will know Michael from the graph community. And so anyway, that was my project, was basically extending Cypher to have these geospatial concepts and mapping that to using the spatial plugin in Neo4j so that you could do an index-backed point and polygon search and have the primitives for these sorts of geometries in Cypher, which was fun. Like Cypher is implemented in Scala, so this was like my opportunity to learn Scala and dig in there.
Is that where you got interested in geospatial? Because I know you've done a lot in that space as well. No pun intended.
Nice. Yeah, I think so. I think it might have been opportunistic that I chose that project. That was, one of the, if folks aren't familiar with Google Summer of Code, it's this like super cool program that Google sponsors. It's kind of like an internship. You get paid a little bit of money, and open source projects can propose projects that they want an intern type, person in school to work on, and you get a mentor from the open source project, and they do a version for docs as well, like Google Summer of Docs maybe is what it's called. But anyway, like I think it was a bit opportunistic. Like I was using Neo4j, and so I wanted to get more involved. And yeah, I think the spatial thing was just kind of opportunistic. But yeah, it really resonated with me. It was super interesting. And I actually ended up going much deeper into geospatial later on. I would always try to work with, like geospatial graphs in Neo4j. When I left Neo4j, so I was at Neo4j for 8 years, and I left Neo4j, I don't know, like a year and a half ago or something like that. It was actually to go work at a geospatial analytics startup that had sort of a plugin for Spark to do large scale sort of data engineering with geospatial data. And I was there for about a year before I went back into the graph game to work at Hypermode, which was what we're talking about today. It was an interesting detour, like to be in a technology ecosystem that was not one I was super comfortable in. Like the data engineering, big data analytics was always a bit, it's always like a bit on the edge of that community. So like I had some experience with the geospatial stuff, but not so much the data engineering, big data analytics, Spark ecosystem piece. But then coming back into the graph space after being away for me years feels like I'm back at home. I feel like there's a lot deeper experience, and I think I know what I'm doing in this space a lot more.
I'm never surprised when people leave and then come back. I'm always surprised when they don't come back. But a quick question on the geospatial. How has the experience in the geospatial world informed how you think about graphs or use cases for that?
Yeah, that's a really good one. So I think if we think about geospatial data, geospatial analysis, like it's just another type of relationship, right? Like things are close together. Things are, within the same polygon, like that. Just another sort of way to represent that relationship. There's this really interesting. I'm gonna try to remember the exact phrasing here. So I think it's Tobler's second or maybe first law of geography is that everything is related to everything else, but near things are more related than distant things. So the phrasing is not quite right, but something like that. And like what's interesting is that in the literature, like he wasn't talking about just physical distance. He was also talking about like cultural similarity and these sorts of things, right? And I think that the geospatial aspect is just like another dimension of similarity and relationships. So that can be like really represented in the graph world in a more like practical implementation focused way. I think that the way we typically like traverse through a graph is you find them starting points based on, I don't know, like if it's a product recommendation, I find like the user that represents or that I'm trying to generate a recommendation for, and that's my starting point in the traversal. And geospatial relationships can just be a way to identify the starting point in your traversal. So we were working with a customer a few weeks ago who told us that the reason they chose Dgraph was that it had much better geospatial support than Neo4j, and my eyes really, or my ears really like perked up at that, because I thought, oh wow, like I've done a lot with the geospatial functionality in Neo4j and looked at this deeper in Dgraph, and what they're doing is essentially there's some areas of interest that represented by a polygon, and then there's some events that occur, and they want to know like what polygon did that happen in, and that's the starting point for their traversal. But then they use that like geospatial indexed query as the starting point and sort of traverse their knowledge graph out from there. So, and yeah, I think there's definitely like a place in graphs for geospatial for sure.
I know there's a lot of interest, especially on the GraphGeeks community. A lot of people that are just inherently interested in geospatial. So I feel like that's just an area we haven't run to ground very well in the graph community, at least the commercial side. We should probably pivot a little bit and tell me a little about Dgraph and what interests you in Dgraph, because it is a different graph model, so to speak.
Yeah. So, I was aware of Dgraph when it was, first. I think the first public release of Dgraph was in 2017, and so at the time I was at Neo4j working on. We called it Neo4j Labs, which is kind of like extensions and integrations. So I didn't work on core database itself. I worked on like tooling around the database that made it easier to use with different technologies and different technology ecosystems. And GraphQL had been open sourced by Facebook in 2016, so something like this. And so this was on our radar because GraphQL has the word graph in it. QL must be a query language for graph database, right? And which that's not really what it is. And I think there was a lot of confusion, and folks were trying to understand. Well, okay, GraphQL makes this observation that your application data is a graph and allows you to query application data as a graph. It's an API query language, right? And there's fundamentally like this separation between your internal database and the API that you expose to your apps, and you don't want this coupling. So like GraphQL is not quite a graph database query language, but I think Dgraph at the time like saw GraphQL as something really interesting, and they also at Neo4j we built a GraphQL integration, and we're of the same mind of like, okay, well, GraphQL is not a database query language, but what if it was? Like, what would that look like? And so this was how Dgraph got on my radar. Was when they launched, they had a query language that they called GraphQL plus minus, and so it was very much inspired by GraphQL, but because GraphQL is not a database query language, they had to add some things to it. So for example, they added this ability to express your like root criteria. So like I was saying, in a graph traversal, you typically find a starting point, often using an index, and then like traverse out from there. And so GraphQL has this like very nested, think of it as like a kind of like a nested JSON document, and that's how you're expressing a traversal, is just this like nested structure, and the data you get back exactly matches like the fields and relationships that you've specified in this traversal. So anyway, so Dgraph took this approach for their query language. The GraphQL plus minus is now called DQL, and Dgraph also added a pure GraphQL layer, because this is another interesting thing we could chat about, which is like the work that goes on to enable graph databases to be your primary application database, like the getting started experience. Or if I'm building a full stack application and I want to use a graph database, I think that graphs are actually like a great fit for that, but it requires tooling that integrates with like the application development frameworks that you're using. Anyway, so that was how like Dgraph got on my radar initially, and then as you look deeper at Dgraph, so Neo4j and Dgraph, I think, take very different approaches in the trade-offs that they've chosen to optimize for, right? So building a database is all like an exercise of choosing trade-offs and optimizing for different use cases. And at Neo4j, the thing they're optimizing for is this concept of like, it's often called like index-free adjacency, or like basically being able to traverse the graph without incurring any network latency, right? So what that means practically is that your entire graph, all of your data, sits in a single machine, and you can duplicate that in a Neo4j cluster, but like fundamentally you're limited to the amount of data that you can fit on a single machine. And of course, like you can scale quite a bit because we can get giant servers, and lots of disk space is cheap, memory is cheap. So in most cases that works fine. Dgraph took the approach of optimizing for scalability in terms of volume, and so the D in Dgraph is distributed, and so Dgraph does sharding out of the box. It's built on a distributed key value store that was actually purpose built for Dgraph called Badger, which is another now open source project that we maintain at Hypermode. But Dgraph takes this approach of exposing to, like, at query time to the developer. I think it still exposes a property graph model, but also internally works with this concept of triples. And so, like, the talk that Amy mentioned that we bumped into each other in Austin at Data Day Texas, I think the title was like, WTF is a triple, my journey from Neo4j to Dgraph. And that was actually like one of the thoughts that occurred to me as I was digging deeper into Dgraph more recently. Is there's all this talk about triples and also property graphs, and I was a little confused because in my mind, like a triple, so a triple is this like subject predicate object, like a way of representing like I don't know what you'd call it, like a piece of the graph, right? It's like, I don't know, like Will knows Amy, Will age, well, I won't say the number, like, the like it represents both, like
it's a concept. Yeah, it's like a linguistic concept. Yeah.
Totally. Yeah. And so, like, we work with that, like, conceptually with Dgraph, and like under the hood, because of the way that the Dgraph is implemented, it's sharding by predicate. And like, so like, for example, if you have, I don't know, user follows another user, like the shards are going to be by that relationship, so that at query time, you're not going to another shard, you're not incurring like network overhead for this traversal. So you still like have this relationship or this concept of index-free adjacency with Dgraph that's optimized for traversals. And that's like a key piece of, like, I guess, why conceptually we are working with triples in Dgraph. But then at like the query data model, you still have this property graph model, which gets mapped onto triples, which I think is like a really interesting approach.
So I have a question for you. So when we normally hear triples and triple stores, the first reaction can be, well, that's for an RDF. That's for kind of an RDF system that we're familiar with, the resource description framework. And I think that's a misconception that happens a lot. Can you talk a little? I don't know if you've had people ask you that, or how it's different than an actual RDF framework.
Totally. That and that was always my understanding as well, right? That there's like the property graph world, and then there's the RDF world, and that these are very separate things and concepts and implementations. And I think that like Dgraph uses like the RDF, like the simplest form of RDF for data interchange, right? So you can like import an RDF file into Dgraph with one command. And conceptually, we work with this idea of subject predicate object, but it's Dgraph is not concerned with I'll just group these things all together and talk about them as like the ontology pieces of RDF and like Shackle and like the query language Sparkle, where you're like leveraging inference and reasoning based on the ontology. Like Dgraph was sort of ignoring those pieces of the RDF world and optimizing for modeling a property graph and optimizing for like large scale traversals was, in like the more, I don't know, like transactional use cases for a graph database, which I think is makes a lot of sense for certain use cases, right? Like if you have large volume of data and you want to do like, very efficient near real-time traversals, like that's the use case Dgraph is optimizing for in its implementation.
So when you talk about use cases, and are there particular use cases that do really well on a Dgraph and Modus kind of backend?
Yeah, so what we're seeing now, and I'm glad you mentioned Modus. I think we should chat a little bit about what that is.
Yeah.
I think like a lot of things in the graph world, like I feel this renewed interest in graphs in the context of knowledge graphs for AI workflows. And so at Hypermode, like we have this vision that, going forward, developers will use models in their apps like that. Like I think there's no question that like the value that models are going to play in software development and in the applications that we build. And so we call this the concept of a model native app, where you have abstractions in the development frameworks that you're using that treat models as a first-class citizen, just the same way that you would have abstractions for working with data or functions in like a serverless environment. Mm-hmm. And so at Hypermode, we've built this open source framework called Modus, which at its core is a serverless API framework. We do some interesting things to support multiple languages, multiple target languages, and we use WebAssembly to do that. So we're adding more and more languages that you can write your logic with. You write a function. We compile that to WebAssembly, and we're also doing some really interesting things with GraphQL, like inspecting the types that you've defined in the language of your choice and looking at the signature of the functions you've defined to generate like one unified GraphQL schema, and expose sort of the way that your models can interact in your function through some abstraction in the framework. Alongside that, like one of those important abstractions that we want to give you in Modus is this concept of a knowledge graph. What I've seen most folks interested in, and like at a high level to summarize it, it's that knowledge graphs provide, more context for the relevancy of the data that you're feeding into an LLM call, right? And so I talk about these building blocks or this like, I don't know, progression of building a model native app. And it's kind of like the first step I feel like is chaining data and LLMs together. This is like a basic RAG pipeline where you're fetching data that is relevant for a specific invocation of the model. You're providing that data, often it's internal business data, providing that as context in the call to the LLM, like a very basic RAG workflow. So we have abstractions for doing this in Modus. Then the next piece is where I want to leverage the model to actually make some decision about the control flow in my application. And this is often done with tool use or function calling. And so the abstraction we have for this in Modus is being able to define this mapping of tools to functions that we're writing in the Modus framework and expose those to the model to say, hey, here are the different tools that you have available. Here's what they do. And you let the model decide the execution plan of like how these tools are called, and they can wrap other APIs or other sorts of logic. And then the third piece, though, of what I see as the building blocks for model native apps is knowledge graph RAG, where you're chaining together internal data and an LLM invocation, but that internal data is represented in a knowledge graph, and you're using these graph RAG patterns, I think is how this is often referred to, as part of the retriever step. So when we're doing like a simple RAG workflow, often we're using like vector similarity search to find documents that are similar in vector space to the user's query. In like a knowledge graph RAG workflow, that may be part of it, but we're also traversing the graph based on the relationships in there to find the relevant knowledge to include in the context of the invocation of the LLM. Mm-hmm. And so these are the pieces that we want to enable with Modus, the framework, plus the way that we're exposing Dgraph inside sort of all one framework. And with Hypermode, we also do model hosting and these sorts of things so that you have all of the pieces together in one framework and one cloud service to build this concept of a model native app.
I feel like that's an important point. And I like that you've expanded it, especially thinking about the different levels of abstraction, because I think right now there is an emphasis on all the different components in an agentic workflow, and kind of tuning those, whether it's a graph RAG component or an LLM response or whatever it might be. But there's not as much emphasis on the entire system itself and how you operate within a system. But I think as time goes on, we're just going to have to be thinking about kind of that bigger orchestration and dynamic responding. So I'm glad you brought that up. For the type of capabilities that Dgraph and Hypermode provide, are there certain use cases or industries that you find that this fits really well into?
So it's interesting. I feel like just in the short time that I've been at Hypermode, which is I don't know, like 6 months or so, something like that at this point, that there's been an evolution of this, and like so much is happening in this space that like things move so quick, which is super interesting. So the sort of first wave of the folks that we were talking to, the use cases were things like search, right? Like I want to improve the relevance of search either in my application or in some like internal system. And I want to be able to leverage like a knowledge graph to be able to do that. And then it was, things like recommendations and I'd say like personalization at large. And it was these cases where like it wasn't a model native app in the sense of like they wanted to like build a completely new application. It was more like, I want to add maybe model native features to an existing application. And, I think like there's a lot of inertia in choosing a new framework to build a greenfield application, right? You have, first of all, you have to know about the framework when you're starting the project, and Modus is designed to be, incrementally adoptable. And so we were seeing things like, I have this maybe internal CMS, and I want to be able to leverage the content that someone is writing in the CMS, but also leverage the internal data that I have about the author or the domain of what they're writing about, that these models don't know about it because it's internal and proprietary, and so I want some way to chain that data to a model. But I don't want to rebuild this entire app. I just want like an API endpoint that I can call from the client and sort of inject that into my web application. And so initially, we're seeing lots of things like that. Whereas I want to add some AI backed feature into an existing app. Also, I think some of the greatest hits maybe for graph use cases, we were seeing folks now wanting to do knowledge graph plus AI for these, and this is like fraud detection, and so we're like seeing a lot of interest from financial services from these sorts of things. But I mentioned this idea of the evolution of the use cases we're seeing, and so now what I'm realizing, and I'm glad you mentioned that this idea of agentic systems is now I think folks are looking at well, how can I make my teams more productive? How can I sort of take existing workflows that may be manual, or maybe I have some like manually triggered AI pieces, right? Like maybe I'm using like ChatGPT or Claude like for a piece of it, but it's still like a very manual process that I have. How can I leverage Hypermode and Modus plus Dgraph to sort of build an agentic system that can replicate or can like enhance the users who are going through this workflow? And so for example, just earlier this week, we had a 2-day sprint with one of our customers, and they have this workflow that they put together, and it's a bit of a creative process. So it involves, like searching, building like custom assets for a specific client and for a specific request, and it involves like searching brand information, doing some research on what that customer is focused on in their marketing, doing some like design work in Figma, like assembling these assets in a certain way. And they're like, hey, like this is great, we're using some AI in a couple of places, but we really want the human to be in the loop here, because there's a lot of value that they provide in sort of the taste making and like the focus on like high quality design. But we know we can automate a lot of this with like tool use and function calling and orchestrating this agentic system. And so we spent 2 days building this out, and we demoed this last night to them, and it was like, wow, like this could really be applied in lots of different workflows. So I think it's still going to help us scale quite a bit, but still like realize that, but the human needs to be in the loop there to sort of use the agentic system as a, I don't know, like a co-pilot or booster. I feel like there's lots of like blur to me, like what is an agent versus a co-pilot? Is it making me more productive versus actually like solving some problem for me? So anyway, to sort of like summarize, I guess what I'm getting at there is like folks I think are now looking for, how can I enhance, build these workflows that I have already, implement these processes that are like well defined, that I've been doing a certain way. I don't want to just like replace someone's job with an agent. I don't think that's like realistic in most cases, but I want to help my folks scale. How can we do that and build some agentic system that replicates a workflow using models, using a knowledge graph, but still have the human expert involved in the process? That I think is like what we're seeing now, a lot of interest in, and I think what I'm most excited about going forward.
Awesome. I would love to talk to you all day, but I have one fun question and then probably one more practical question. I'll do the practical one first. One is just tips for people that want to get started with Dgraph and kind of figure out what that's all about.
Yeah, so probably the easiest way to get started is to sign up for Dgraph Cloud instance. So I'm sure we'll put the link in the show notes for folks to get started there. That's a good way to get started. We're also doing a lot of work to integrate Dgraph into Modus. So we have a YouTube channel where we have some examples. We have a GitHub repo that we call Modus recipes, which has things that are built with Modus and Dgraph. We also, I should also say, like we talked a lot about Neo4j and Dgraph here. Like at Hypermode, we want to support any knowledge graph that our users are using. So we added Neo4j support to Modus. We have folks using Neo4j with Modus. We have some examples in Modus recipes. So like certainly the takeaway is not like you should use Dgraph instead of Neo4j. Like they're both great graph databases that have, like I said, different approaches to the same problem, and even other knowledge graph tooling we're adding support for in Modus. So anyway, that I think would be a good resource. It's also really easy to get started with Modus. There's a CLI that you install, and you say Modus new and start building from there. But probably looking at one of our existing Modus recipes is a good way to get started.
Awesome. That sounds great. Also, anybody on Discord, anybody in the GraphGeeks Discord, just know that the Hypermode has a very active Discord as well. So one final fun question. I am fascinated with serendipity and unexpected connections. So I would ask you, Will, during this journey, at least the last 12, 15 years, journey, what unexpected connections surprised you the most?
Oh, wow. That's an interesting one. Well, I will say, like, the world feels quite small when you look at like the people that you've worked with in like very different contexts that you end up reconnecting with, or staying connected with, and so I'll say that my boss, like the CEO of Hypermode, is someone that you and I both know from working with at Neo4j, Kevin Van Gundy, and we worked with Kevin early on at Neo4j. I was on the developer relations team. He was in the sales organization, and it just amazes me the kind of folks that I meet connected to this graph world from working on projects previously that we're again working on projects now. Actually, this 2-day sprint that we did was with also someone that we know from the Neo4j world previously. The connections that you build like years or decades ago, like these folks will come back into your life and still enable great things going forward. So yeah, I'd say that's probably one thing that at the time I wouldn't have expected. And actually, like going back to Kevin at Neo4j, I remember Kevin and I did a workshop at NASA, and our connection at NASA later on was the CTO at Dgraph briefly, like years later. So it's amazing, kind of the folks that have influence in your life and projects going forward in the least expected spaces, for sure.
Yeah, thank you. That is a fun aspect, and I don't know whether that's a graph type of thing that people that get in graphs tend to do that, or if that's just a natural thing and you just don't realize until you see the ripple effects years later. But it is absolutely one of the things I like the most about the graph community. So thank you, everybody, for listening. Thank you, Will, for your time. Very much appreciated. Always lovely talking to you. And I'm looking forward to talking again later this year.
Cool. This was fun. Thanks, Amy.